Hello friends, welcome to Infotalks. It's all about concepts. Let's continue today with cross-cutting concern patterns, which is one among 5 groups of microservices design patterns. We have divided this presentation in 5 parts, one per group for convenience. So again, if you landed here directly, then prior to this presentation, I would request you to please go through MSA Design Pattern Part 1 to understand at high level what is design pattern, and also to look at the overview of all the 5 groups of microservices design pattern. Okay, so let's see cross-cutting concern pattern. It includes 4 design patterns: external configuration, service discovery pattern, circuit breaker pattern, blue-green deployment pattern. The problem or question that cross-cutting concern patterns solve is how to make our services fault tolerant and achieve resiliency. How to make our APIs always available, high availability. How to run services in multiple environments without modification. That is, how to reuse the configuration. So let's get started. And the first one to look at is external configuration. Configuration reuse can be achieved by external configuration pattern. Most of us might have used this pattern where we have config files for different environments commonly implemented in traditional world as well. For microservices, the implementation at high level is as per this diagram. This reduces defects due to incorrect config across different services. This is useful when we are using third-party services and need to map our services from different environments to the pre-prod and prod instances of the third-party service. Externalized configuration essentially provides an option for service to read configuration dynamically. So, externalize all application configuration, including the database credentials and network location. On startup, a service reads the configuration from an external source. One example as shown here. Spring Boot externalized configuration reads values from a variety of sources, which includes OS environment variables, property files, and command line arguments. These values are available within the Spring application context. With this pattern, we achieve reuse, availability of environments, and standardization of configurations. As this is all services interactions, meaning we always have URLs to call which might keep changing or be dynamic in nature. Like VMs are usually assigned dynamic IP addresses, also known as ephemeral IPs. Unless we configure static IP, the IPs will change after each reboot of the server. Then how do we keep clients non-impacted? Service discovery is the pattern for our rescue. So basically, we will have all services registered on discovery server. Then for client, there are 2 options. 1. Client-side service discovery, where client will ask discovery server about the URL of the service that needs to talk to, and discovery server will provide the address, and then client can call the service. Second option is server-side discovery server. Here, client will let discovery server know that this is the message I want to pass to a particular service, and discovery server will identify that service from registry and pass on the message to the intended service. So with this pattern, we achieve resiliency, abstraction, and high availability. Next is circuit breaker pattern. Our service needs to have high fault tolerance, meaning our service should be able to auto recover from failures. The problem that we are addressing here is to prevent a service failure from cascading to the other services. Circuit breaker pattern can be implemented to recognize if service is good or it's failed. We need to implement a logic to check the failure. If it reaches a threshold, then activate fallback service. Then after a predefined time, check if the failed service is responding to the test request. If true, then switch back to the main service, else continue on fallback service. This provides resiliency by design for service failures, and also limits the cascading failure effects. Tech giants like Amazon, Google, and Netflix release their new features almost every hour. So, how is this possible? Initially, the new feature is released to their employees or a small set of pilot consumers. So, the employees or the pilot consumers here are canary. The router diverts some traffic to specific consumers. This gives them time to fix any issues, and once provided, then the rest of the traffic can be diverted to the new service. This is called blue-green deployment or canary deployment. Essentially, here we have two sets of environments. The existing production environment is called the blue environment, and the new identical environment with the newer version having the new feature is the green environment. This pattern reduces the blast radius for faults or defects dramatically, as the impact is just to the very small internal or test users. So we get to test all this directly in production environment and without any downtime to the existing production environment. In combination with auto rollback, this pattern can eliminate the need for any embargoes, as we will not need any downtime at all. We achieve high availability, and this also helps continuous deployment and faster time to market features from DevOps. This covers cross-cutting concerns patterns. For more videos to clear your concepts, please visit infonester.com. If you find this video useful, then please do subscribe for notifications. Thanks. Bye for now.